Until now, the ability to travel faster than the speed of light has only been seen in sci-fi movies. But what if we can actually make that a reality? If we ever hope to visit other parts of our galaxy, we'll have to travel at speeds we've never imagined. A possible solution to the problem of traveling at the speed of light or even faster is the warp drive, popularized by Star Trek. The sci-fi franchise is still ongoing. Therefore, if we could find a way to bend or warp space-time, we would be able to move around the cosmos in the blink of an eye. Warp drives have mostly remained the preserve of science fiction. However, a number of new discoveries by a German physicist about the nature of space and time imply that Einstein's purportedly unbreakable speed limit may not be so unbreakable after all. Does that mean it's possible to travel faster than the speed of light by warping space-time? And in doing so, have we also discovered the key to exploring the universe? It's widely accepted that no known object can travel faster than the speed of light in a vacuum, which is 300,000 kilometers per second, as stipulated by Albert Einstein's famous special theory of relativity. Humans are unlikely to be able to send spacecraft beyond our own Milky Way galaxy because of this speed restriction. It's only possible for a particle to travel at the speed of light if it has no mass. So far as we know, nothing can be accelerated faster than the speed of light using the current laws of physics. When you look at it from a different perspective, however, this limit only applies to the universe's four-dimensional space-time. Outside of that, it appears that even faster speeds are feasible. There is no doubt that humanity will never be able to travel the length and breadth of the universe with our current technology. A beam of light takes more than 4 years to reach Proxima Centauri, Earth's closest star. It would take tens of thousands of years for a human to get there, even with the best existing propulsion engines. One can always fantasize about building colonies in other star systems, but no one is likely to make the journey. However, it is feasible that the journey time could be reduced in the future. From laser-accelerated solar sails to nuclear propulsion, there are a variety of options for doing so. Even with these technologies, though, you wouldn't get very far in a human lifetime. Only those who travel at the speed of light or faster have access to the cosmos. As a result, imaginative physicists have long pondered the ultimate propulsion system, a bubble in space and time through which a spaceship could race from sun to sun, much as the USS Enterprise did. This is science on another level, not necessarily incorrect, but laced with a healthy dose of optimism. Thanks to a 1994 publication by Mexican theoretical physicist Miguel Alcubierre, scientists are even discussing the concept today. Albert Einstein's theory of relativity is divided into two components for physicists. The special theory of relativity, which originates in 1905, is concerned with the uniform motion of objects moving at the speed of light. Einstein generalized these theories for accelerated bodies 10 years later. General relativity states that the three spatial dimensions we are most familiar with, up, down, left, right, and front, back, are inseparable from time. Therefore, every mass distorts the fabric of space. We exist in a four-dimensional space-time, according to Albert Einstein's groundbreaking discovery. So there is no such thing as static space-time. It deforms like a tablecloth when it comes into contact with larger items. Therefore, everything that moves across the tablecloth or space-time can only travel at the speed of light. The tablecloth, on the other hand, can deform at any rate, as the cosmos has demonstrated in some instances. For example, at the time of the Big Bang, the initial space-time structure apparently stretched for a fraction of a second, far faster than any ray of light could travel. Even today, the expansion continues to accelerate the movement of extremely distant galaxies away from us at speeds faster than light, preventing their light from reaching us. Alcubierre surmised that a warp drive was only a small step away based on his discovery. The ability to travel faster than light could be achieved by condensing space-time in front of a spaceship and expanding it behind it. The crew would be protected from the enormity of the interplanetary travel since the ship would be encased in a bubble. However, expressing this idea in the language of general relativity immediately raises substantial practical difficulties. To begin, you'd need to jam a massive mass inside a bubble with a wall thinner than an atomic nucleus to bend space-time so dramatically. To keep the bubble going, you'd need two types of matter. Ordinary mass's gravity would drive the space in front of the bubble to contract, propelling the entire structure forward. In addition, the space at the back of the bubble would need to grow like rising bread dough at the same time. According to Alcubierre, to achieve that expansion, you'd need some kind of negative energy emitting anti-gravity, which no one knows how to create. However, this warp drive concept has been given new life by an astrophysicist who has discovered new ways to bend space-time. How is that possible? It's made possible by Dr. Eric Lenz, a physicist at the University of Göttingen in Germany who discovered new ways to travel faster than light by constructing new forms of space-time bubbles around a spaceship by delving deeper into Einstein's intricate theory. They're referred to as solitons, and they're identical to the ones proposed by Dr. Alcubierre. However, Eric Lenz's breakthrough discovery is that some of these bubbles can be created using conventional material. It all started with Star Trek for Eric Lenz. Captain Jean-Luc Picard would raise his hand and order Warp 1 engage every few episodes of Star Trek The Next Generation. Then stars turned into dashes as light years flew by at unfathomable speed. And Lenz, who was still in elementary school at the time, questioned if warp drive could be made into a reality. Traditional energy sources, according to Eric Lenz, may be capable of structuring the structure of spacetime in the form of a soliton, a powerful solitary wave. This soliton would function as a warp bubble, compressing space in front of it while expanding space behind it. Spacetime, unlike anything within it, can bend, expand, or warp at any speed. As a result, a spacecraft trapped in a hyperfast bubble may travel faster than light in normal space without violating any physical constraints, not even Einstein's cosmic speed limit. So, when will we see the first of this space starship? It would be a significant investment with a huge return. Proxima Centauri, the nearest star, would take over 50,000 years to reach with the present rocket propulsion, but the journey might be completed in 4 years or less if done at the speed of light. However, despite the apparent conformity of Eric Lenz's solitons to general relativity, space agencies will not be developing warp drives anytime soon, if at all. The first true spaceship seems to still be a long way off. There are a few snags in the system that need to be worked out. In part, it's because Lenz's positive energy warp drive demands a lot of energy, as was mentioned earlier. A spaceship with a radius of 100 meters would require energy equivalent to hundreds of times the mass of Jupiter. According to Eric Lenz, making a spacecraft like the Enterprise travel faster than light would need the same amount of energy as destroying a tiny star. To be realistic, this demand would have to be cut by around 30 orders of magnitude to match the output of a current nuclear fission reactor, according to him. Nonetheless, he expects that technological advancement will dramatically cut this figure in the next decades. Many other problems would also have to be overcome for a warp drive to be practical. The horizon problem is one of the most harmful, according to Alcubierre, who considers Lenz's work a major development. According to him, a warp bubble traveling faster than light cannot be generated from within the bubble, since the leading edge would be beyond the grasp of a starship sitting at its center. This is an issue since you'd need a lot of energy to deform space to its very edge, and the spacecraft just doesn't have the capacity for that. While acknowledging the enormous challenges of developing a warp drive, Eric Lenz is certain that they can be overcome. This work has moved the problem of faster-than-light travel one step away from theoretical research in fundamental physics and closer to engineering, he says. Following the energy requirements, Lenz intends to devise a method of creating, accelerating, dissipating, and deaccelerating positive energy solitons from their constituent matter sources, then confirm the existence of small and slow solitons in a laboratory, and finally address the horizon problem. With this, he says, we will be able to break the speed of light with an autonomous soliton. On the other hand, Eric Lenz is making strides toward putting his concept into action. He went to work for an IT company after finishing his research in Göttingen. In his leisure time, though, he continues to consider ways to accelerate a bend in space-time to speeds faster than light while reducing the energy necessary. How about digging a tunnel across the stars? When it comes to traveling through space, space-time bubbles aren't the only option. Einstein himself experimented with the idea of tunneling through the fabric of space-time using so-called wormholes. Until recently, these were likewise assumed to necessitate the use of strange materials. Recently, researchers suggest that ordinary matter could be the key to solving this mystery once more, according to a team of theorists. If proven, wormholes could become the ultimate mode of interstellar travel. Another group of theorists' calculations predicts that it may be able to utilize them to travel across the galaxy in less than a second. Perhaps by drawing inspiration from science fiction and daring to dream, humanity may one day be able to explore the outer reaches of our solar system.